In this video, I am going to discuss about some of the problems given in the VTU question papers. I have considered only 4 question papers of 2018 and 19 of DA paper on dynamic programming. Most of the problems are repeated from the videos what I have already covered. Some of the problems which are not discussed, I am going to discuss it now. Okay, the first, let us take the first problem. So the first question is define transitive closure of a directed graph. Find the transitive closure for the given graph whose adjacency matrix is given. This was asked in July 2019 for 10 marks. So defining transitive closure of a graph will, if you define it, there will be 2 marks. Of course, you can take it from the book or from the previous video. They may ask you to write the algorithm, hardly 4 lines of code, which include this line, 3 for loops, and this line, 1 for I, 1 for j, 1 for k, ranging from 1 to n, and this formula if you write, then partial algorithm over. So for that, in that 3 to 4 marks, and solving this problem for 4 marks. So let us start solving this problem. So given adjacency matrix itself is R0, our R0. So Warshaw's algorithm tells us that when you are going to find R of k, I, j, any element of R raised to k, we need to depend on the previous matrix what we have got. So the either previous matrix value is 1, then we will take that value, or we will consider the previous matrices I, j element, sorry, I, k element, or k, j element. If both are 1, that will become 1, either or it will be 0. It is something like that. If this I row j column entry is 0 and k row entry is 1, then this will become 1. This will also become 1. That is what the Warshaw's algorithm tells us. So to find R of 1, let us consider the first row and first column of R0. So that row and that column will not going to change in R1. So let us write them as it is. So it is 1 0 0 1 0. This is 1 0 0 1 0. Okay, they are not going to change. So now, as this entry is 0, so the remaining column of that row will remain as it is. Well, there will not be any changes. So we can directly write it from the previous matrix. So that is not going to change. Again here, the third row is starting from 0 because we have considered the first row and first column. So if this is 0, then the remaining will remain as it is. So it is 0 0 1 1. See that this entry is 1. So there are chances that the entries in this row are going to change. And again, this is 0, this is 0. So first 3 columns are not going to change. So it is 0 0. See that this entry is 0. This entry is 0. That is deep row, deep column. But here it is 1 and here it is 1. So we need to consider this. So this 0 will become 1 because the previous row entry is, previous matrix entry is 0, but kth column, kth row entry is 1. So it is going to change from 0 to 1. And this entry is 0, that is this column is 0, so it will remain as it is. And as the last column first entry is 0, this is not going to change. So we have got only one element changed in this matrix. I hope you have got it. So now we will go for R of 2. from this matrix we need to find it. So we need to consider the second row, second column. The very first thing is second row, second column are not going to change. So directly we will write the second row, that is 0, 1, 0, 0, 0. From this I have written. And the second column, that is 0, 1, 0, 0, 0, 0, 1. Now, to make this entry, we need to consider this item and this item. Both are 0, and also the previous matrix value is 1, so it is not going to change. As this is 0, this will not be affected. So it will be same 0, 1, 0. And this is 0, this row is not going to change. This 0, 0, 1, 1. And again, this is 0, this row is not going to change, it will remain as it is 1, 0, 0, 1, 0. See that this entry is 1, there are chances that this row may change, but all these entries are 0, so nothing is going to change in the last row. 0, 0, 0, 1. So now from this matrix, let us find RP. A, B, C, D, E. So we need to consider third row and third column. See that these two are 0, these two are 0. So there are no chances that this part of the matrix is going to change. Let us write the third column and third row first. 0, 0, 0, 1, 1, 0, 0, 0, 0. See, these two are 0 and these two are 0. So definitely there will not be any changes. It will remain as it is. 1, 0, 0, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 1. Because this is 0, the whole column itself is 0. So if we consider that, it is not going to affect any other columns. So next we need to find R4. So this will be so we need to consider fourth row and fourth column. There are 2 1s here. Here also there are 2 1s. So there are chances. So let us write that directly. 1, 0, 1, 1, 0. And 1, 0, 0, 1, 0. So let's see that this is already 1, so no need to change. And we to make this entry, we need to consider this element and this element. This element is these two are 0, so these two columns are not going to change. Write it 0, 0, and this is 0, so it is also not going to change 0, 0, 1, 0. Okay. Now, this is 1 and this is 1. This is 1 and this is 1. So, definite this 0 will become 1. And these two are zeros, so it is not going to change. Zero. Now this is 0, so it is not going to change. This column, this row is not going to change. Now to find R5, which is the last matrix, which will be the transitive closure, we need to consider this row and this column. So let me write that here. Because there are 5 vertices, we need to find R5. We need not to go further. Say this is 0, so first column is not going to change. First, let us write the fifth row and fifth column directly. 0, 1, 0, 0, 1, 0, 0, 1, 0. Now, this is 0, so directly we can write the column 1, 0, 1, 1. And now this is 1, there are chances. So this is 0, so it is 0. 0, this is also 0, so directly no need to change this. Both are 0, so they will remain as it is. See that this is 1, this is 1. So this 0 will become second row, third column. So that will become 1. And these two are zeros, so it will remain as it is because of these two zeros. And now this is 0, so it is not going to change. So this is the final transitive closure what we have got. So if we want to cross check what it is, let us see whether what we have done is right or wrong. So there are 5 vertices. Say let us take A, B, C, D, and E. So there is an edge from A to A. There is an edge from A to D. So from B there is an edge from B to B. There are no other edges. From C there is an edge to D and to E. From D there is an edge to A. So this is bidirectional. Can take like this. And from E there are 2 edges, A to B, 1 edge, and from to E only there is another edge. Let us cross check. There is no change in the first row, and from the second row there is no change. In the third row there are changes. So C to A there is a path. It is telling that there is a non-trivial path. C to A. How it is? See that C to D, D to A, there is a path. Yes, this is right. This is right. And C to B, it was not there here. There is no direct path C to B, but there is a path that is E to E, E to B. So there is a non-trivial path. And C to D, of course, there is direct path C to D and C to E. There are direct paths. And from D D to A there is a direct path. D to D, it is showing D to D. So D to A to D, there is a path. So this is also right. Then E to B, there was a direct path, and E to E, there is a no change. So actually, there is nothing much change in this from this to transitive closure. The question is bit strange, but still, as they have given, we have solved it. So only thing we need to consider is we should go on constructing the R naught to R5, R naught to R5, such that in the every step we need to consider one row and one column. Okay, we can get the answer. We will see another same problem on the same topic. We will consider one more problem which was asked in December 2018, January 2019 question paper. It was asked for 8 marks, and the question was define transitive closure of a graph, write the Virchow algorithm, then apply that for the following adjacency matrix. So again, this is comparatively simpler problem because there are only 4 vertices. So let us consider this as R0. So to find R1, we need to consider the first row and first column. See that the first column entry is 0. So there will not be any changes in R1. R1 will be similar to that of R0 because 8 column entries are 0. So they will remain as it is 0, 0, 0, 0, 1, 0, 0. The whole matrix will remain as it is. Now, we will solve it quickly. So to find R2, we need to consider the second row and second column. We will write the second row, second column directly. And we can also write the diagonal because diagonal entries are zeros. So see that this is 0. 8th row, seat column entry is 0. But bth row, bth column entry for that element is 1 and 1. So 1 and 1 will become 1. 0 or it is 0 or 1 and 1. So 1 and 1 that will be taken the priority. So it will become 1. And this is 0. So 1 and 0 will become 0. And here these two are zeros. So nothing is going to change. So now, to find R3, we will have to consider third row and third column. See that these two are zeros. So there will not be any changes in the first and second column. So directly we can write R3 first let us write third row 0, 0, 0, 1, third column 1, 1, 0. So as these two are zeros, these two are not going to affect. So they will remain as it is that of R2. 0, 0, 0, 0. This is 0, 0. And now for these two entries, this is 1, this is 1. So this is 1, this is 1. Definitely this entry is going to affect. Earlier it was 0, so it will become 1 now. And earlier it is 0, this entry, this is 0, this is 1, this is 1, so definitely this 0 will be changed to 1. And this is 1 and this is 0, so it will remain as it is. So let us find R4. A, B, C, D. A, B, C, D. We need to consider fourth row and fourth column. See that there is a mistake here. This is 1. This is 1. Just I have mistakenly written. Now, see that these 3 are 0. If these 3 are 0, the remaining part of these columns are not going to change. They will remain as it is. So, definitely there will not be any change, even though we have all the ones in this column. So, directly we can write, there is no difference between R3 and R4. Directly we can write it. If you have not at all solved these problems earlier, then watch the video of functional algorithm on dynamic programming. Definitely you will understand the concept. Then again come back and watch this video. The description in the description, the links for those videos are given. So if we want to cross check, then it will be, there are 4 vertices A, B, C and D. So A to B there is an edge. B to C there is an edge. And C to D there is an edge. There are no other edges. So let us cross check whether there are paths like this. This will give the adjacency matrix, and this is giving us transitive closure of that. Means, is there any non-trivial path from one vertex to another vertex? So A to B there is 1, so there is direct path. A to C, A to B, B to C, there is a path, so this is also right. And A to D, 1 is showing, it means that there is a path. So A to B, B to C, C to D, there is a path. Yes. B to C there is direct edge. B to D, it is showing the path. Yes. B to C, C to D, there is a path. And from C there is a direct edge to D, that is 1. And from D there are no paths, so there are no outgoing edges here. So all the entries are 0, 0. All the entries are 0. So whatever we have solved is right.